This one. This is gonna keep you up while you sleep tonight. The hollow moon theory. Our moon really doesn't make sense when you look at the facts. Like, it shouldn't exist. The moon is about 25% of Earth's size, the biggest moon to planet ratio of our entire solar system. Pluto's not a planet, that doesn't count. That's 72 times larger than the expected average moon to planet ratio of our solar system. Moons are just not supposed to be this big relative to their home planet, but sure, maybe we got lucky. Despite this, the moon is only 1% of Earth's mass. 1%, meaning it is way lighter than it's expected to be, and we really don't even know why. Unless, of course, the moon is either extremely porous like a sponge or a hollow shell. When looking at this data, NASA's own Dr. Gordon McDonald even said himself it would seem that the moon is more like a hollow than a homogeneous sphere. But oh, that's just the tip, and we ain't stopping. Our moon's orbit is way closer than that of any of the other over 400 moons in our solar system, and also has a near perfectly circular orbital path. We don't see this on any other planet, which all have moons with wildly eccentric orbits. Our moon also coincidentally appears as the exact same size as the sun in our sky. Despite our sun having a diameter 400 times larger than the moon just so happens to be exactly 400 times closer to us, defying all odds of randomness, but is officially deemed just a cosmic coincidence. The moon also happens to be tidally locked with our planet, meaning its rotational period is the same as its orbital period around the Earth, which is why the same side is always facing us. This one is not so much a coincidence, as tidally locked moons are actually fairly common in our solar system. But it would also be the perfect excuse for the moon to always look the same in our sky, and for us to never see what's on the other side, like an all-seeing eye that never ceases surveillance of our planet. We don't even know for sure how our moon even got there in the first place. The most common explanation is that the early Earth collided with a massive protoplanet called Theia about 4.5 billion years ago, which was thought to be roughly the size of Mars, and the impact caused the resulting debris to coalesce and eventually form the moon. This is known as the giant impact theory. There's also the fission hypothesis, where an early molten Earth was spinning so fast that a part of it got ejected out into space and became the moon. The capture theory, implying the moon just drifted by Earth and was captured by its gravity. And the accretion theory, suggesting that as the early Earth was forming in its accretion disk, a part of that disk clumped together to become the moon. But when studying rock samples from the surface of the moon, we find out that none of these theories quite make any sense, with other NASA scientists like Dr. Robin Brett further quoted as saying, "It seems much easier to explain the non-existence of the moon than its existence. Like on Earth, the newest rocks are on the surface, and the deeper we go, the older the rocks get, as we would naturally expect to be the case. On the moon, it's the other way around. Soil samples from the moon confirm that older rocks are on the surface, and they get younger the deeper we go. The only time we ever see this inverse relationship of rock layer depth to rock age on Earth is through human interaction, like drilling, digging holes, and boring tunnels. Did the same thing happen on the moon? If the moon was hollowed out from the inside, this older inner rock would be brought up to the surface, and this observation would make sense. The lunar crust is also thinner on the side of the moon facing the Earth and thicker on the dark side of the moon, and researchers still have no idea why. The moon doesn't have a magnetic field, much the same as other planets' moons, but strangely, moon rock samples are strongly magnetized. Craters on the moon are all virtually the same depth, no matter how big or small they are. On Earth, bigger craters naturally go much deeper than smaller ones, as the impact was greater. Not on the moon, almost like there's a solid layer underneath preventing the crater from going too deep. Moon rocks are also much older than the oldest rocks on Earth by millions of years, blowing the fission hypothesis and accretion theory out of the water. The moon contains traces of uranium-236, a radioactive isotope that doesn't occur naturally on Earth, but rather through the highly complicated scientific process of nuclear fission, something that only an intelligent species is capable of. Zirconium, chromium, and titanium are all relatively rare Earth metals, but are somehow quite abundant on the moon. Those three elements are also some of the most durable and corrosive resistant that we know of, perfect for building a massive structure. And they've even done quantifiable experiments that tell us that's exactly what the moon might be. When Apollo 12 was leaving the moon's orbit, they intentionally dropped their lunar lander down to the surface. When it crashed, seismic measurements showed that the moon reverberated and rang like a bell for an hour. They did not expect this. Only hollow objects are expected to reverb like this, especially with something as small as a lunar lander. During Apollo 13, they tested that again with a much larger object, dropping a spent Saturn V booster rocket that impacted the lunar surface. This time, the moon rang for 3 hours, with vibrations going as deep as 32 kilometers beneath the surface, and even got faster the deeper they got. This doesn't happen on Earth, or even solid objects for that matter, and again is only expected to occur on something hollow.